Hey everyone, it's Justin again. Now that we've reviewed the Pythagorean theorem, let's review one more topic so that we can find specific values of the sine, cosine, and tangent functions. Just like last time, don't worry if this looks new. This lesson is also designed so that you can still learn it for the first time if you've never seen it before. Let's get started. By the end of this lesson, you should be able to fill in the two missing sides given one side in a 45-45-90 triangle or a 30-60-90 triangle. First, we'll review the 45-45-90 triangle, and then we'll review the 30-60-90 triangle. These special triangles are so special that they get special treatment. They're named by their interior angles. Here's a picture of the 45-45-90 triangle. It's actually half of a square. So its two legs are the same length. Here is a picture of the 30-60-90 triangle. It's actually half of an equilateral triangle. So its hypotenuse is twice as long as its short leg. Here's that 45-45-90 triangle. For these ratios, we will always label the short leg x. Look! Since you have two sides of a right triangle, you can use the Pythagorean theorem to find the length of the missing side. Pause the video now and give it a try. Let's consider A and B to be x, and we'll remember that the hypotenuse is c. Now, combine the x squared terms and switch the sides since we're really wanting to know the length c. Take the square root, and we'll simplify it this way. So, this is the length of the hypotenuse. Fortunately, these ratios will hold true for any 45-45-90 triangle. Let's use this to solve some problems. Here's a 45-45-90 problem. Find the value of x in this following triangle. When we encounter a 45-45-90 triangle, we may have to first notice that it actually is one. If there is a right angle and one 45-degree angle, then the other angle must also be 45 degrees, since the angles of a triangle add to 180 degrees. Let's take a look at our chart from the previous slide. We'll match our hypotenuse to the hypotenuse on the chart, and match our leg to the leg on the chart. You could actually match it to the other leg if you want. Now we have one other confusing issue. The x in our problem is not the same x as that in the chart. If you ever have a conflict of variables, you can always change the variable in your chart to something else. So let's use A for this problem. Now let's look at our arrows and write the most obvious comparison first. It's always a good idea to start with the number in your problem. So we have A equals 3. Now let's go to that other arrow. The other equation would be that x equals A times the square root of 2. We're almost done. Since A equals 3, let's plug that in to get x equals 3 times the square root of 2. For a second example, find the length of the missing sides in the following triangle. Try pausing the video to see if you can set this up with the chart. Okay, here's our chart. So let's first label our unknown sides. Since our standard chart uses x, let's label the missing sides A and B. Wait. The missing sides are the same length of a 45-45-90 triangle. So let's label them both A. Now let's match the side with a number to the chart, which in this case is the hypotenuse. The other match can be either leg of length A in our question to either leg of length x in our chart. So we'll just choose the easiest one to draw. Just like last time, we'll start with the equation involving a number, which gives us x times the square root of 2 is equal to 6. Pause the video now and see if you can solve for x in its simplest form. Okay, let's solve for x by dividing both sides by the square root of 2. Oh no, it's a square root in the denominator. We really should simplify that. So let's multiply the numerator and denominator by the square root of 2. This gives us x equals 6 times the square root of 2 all over 2. As one final step, notice that 6 divided by 2 is 3, giving us that x equals 3 times the square root of 2. Finally, let's use the other arrow to get that A equals x. Oh, this is wonderful because we already have x. A equals 3 times the square root of 2. Therefore, the length of both missing sides is 3 times the square root of 2. Here's a 30, 60, 90 triangle. For these ratios, we'll always label the short leg x. Remember, when we looked at this one earlier, we discovered that the hypotenuse is twice as long as the short leg. So since the short leg has length x, the hypotenuse has length 2x. Look, since you have two sides of a right triangle, you can again use the Pythagorean theorem to find the length of the missing side. Pause the video and give it a try. Let's consider A to be the unknown side length and B to be the short leg length, x, and the hypotenuse is always c. Let's put that in Pythagorean theorem. Now, let's rewrite our squares. And since we're trying to find the length A, we'll subtract x squared from both sides. Take the square root, and we'll simplify it this way. So, this is the length of the long leg. We've once again found a useful chart now for the 30, 60, 90 triangle. Let's solve some more problems. For a first example, find the value of x in the following triangle. Just like earlier, we're missing an angle. If there's a right angle and either a 30 or 60 degree angle, then we get a 30, 60, 90 triangle, since the angles of a triangle always add to 180 degrees. Let's take a look at our chart from the previous slide. We'll match our hypotenuse to the hypotenuse on the chart, our short leg to the short leg on the chart, and our long leg to the long leg on the chart. Just like last time, since there is an x in our problem, let's change the variables in the chart to a. Which arrow should we start with first? We'll start with the side with a number, giving us 2a equals 8. Dividing both sides by 2, we'll get a equals 4. By the way, this is our short leg length. However, we want to know the long leg length. We get x equals a times the square root of 3. We're almost done now. Since a equals 4, let's plug that in to get x equals 4 times the square root of 3. Here's another example. Find the length of the missing sides in the following triangle. Try pausing the video to see if you could find these missing sides. Okay, here's our chart. So let's first label our unknown sides. Since our standard chart uses x, let's label the short leg a and the hypotenuse c. Now let's match the side with a number to the chart, which in this case is the long leg. The other two will be c matching 2x, the hypotenuse, and a matching x, the short leg. Let's start with the long leg. Our first equation is x times the square root of 3 is equal to 6. So let's solve for x by dividing both sides by the square root of 3. Ugh, there's that square root in the denominator again. Let's simplify that by multiplying the numerator and denominator by the square root of 3. This gives us x equals 6 times the square root of 3 all over 3. But this is just 2 times the square root of 3. Next, let's notice that we can use the short leg to immediately find its length to be a equals x, which is 2 times the square root of 3. Finally, using our hypotenuse, we get c equals 2x. And then we plug in our x again. Simplifying, we get that hypotenuse has the length 4 times the square root of 3. Today, we reviewed 45, 45, 90 triangles and 30, 60, 90 triangles. In our next lesson, we're going to use these to start building up some special values for the sine, cosine, and tangent. See you then. Hey, hey.